Hi guys, we're going to talk about section 1.4 here. It is my opinion that this is one of the trickier sections of the chapter. We're going to be dealing with a lot of writing equations of lines. As you're doing this notes with me, you might want to pause the video and work on problems with me to make sure you're understanding it. And I also want to remind you when you're doing the math lab, sometimes they will tell you to do a problem a specific way. You do not have to do it a certain way. You can do it whatever way you feel comfortable with. If you view an example and it's walking you through a way that you would rather not do the problem that way, just skip it, come to office hours, and I can help you from there do it the way you feel more comfortable. So we're going to talk about equations of lines. In this slope-intercept equation, y equals mx plus b is the number one equation whenever we're writing equations because it's very easy and straightforward. The slope is right in front of the x value and the b is the y-intercept, and that's all you need to graph or write equations of lines. All you need is m and b. If you know those two things, you can write the equation of any line. So we're going to use this to start with on some of these problems, and then eventually we're going to get into some point slope methods. But this guy will work every single time. So let's look at this first example, which is pretty easy and straightforward. A line has slope -7/9 and a y-intercept of 0.16. Find the equation. Well, this is a very easy one because they tell me the slope, which is the m, and they tell me the y-intercept, which is the b. All you need is m and b to write an equation of a line. So you go right to plugging it in. Y equals -7/9 x plus that b value of 16. So that one was pretty easy, and it's going to get a little bit more tricky, of course, as it always does. So here's the next one. This time, they give me a slope of -2/3, so that's my m value, and they don't tell me what the b is. They tell me instead a point, which is -3.6. We said all I need is m and b, but they did not give me b, so that's what I have to find. There are a couple ways you could do it. You could graph it. I've seen kids do this before. This is not a reliable method at all, but kids will graph. They'll go -3, they'll go up 6, and they're like, okay, I need to slope it out from here, -2/3, down to over 3, and they can see that that y-intercept is going to be at 4. Now, you can see it on this equation, but sometimes y-intercepts do not fall on lattice points. They're in between values. You would not be able to tell where it would cross if it was an in-between value. So for this example, it's nice because we're going to be able to check to see if it's 4, but this method is not reliable. Instead, you should use the mx plus b or point slope formula, which I'm going to talk to you about in a minute. So they tell me the m is -2/3, but they don't tell me what the b is. Instead, they give me this point. So this point is an x value and a y value. I can plug that into this equation. Y is 6, -2/3 times x, which is -3, plus b, and I can solve it for b, which is what I needed for my equation. Now, you will multiply this out. I will get 6 equals. Those 3's will cancel, and it will leave me with a +2. Or you could type in your calculator -2/3 times -3 to get the 2. You subtract 2 from both sides, and we get that b value of 4, just like our graph showed us, so b is 4. Once you know m and b, you can write the equation of any line, and the equation is going to be -2/3 x plus b, which in this case will be 4. There is another route you could have taken with that problem, and it is called point slope formula. Point slope formula is good as long as you remember it. The problem with equations and formulas is if you don't know them, they can't help you. Kids do sometimes forget this. The equation is y minus y1 equals m x minus x1. A way you can remember it that might help you is if you remember that the formula for slope is y2 minus y1 over x2 minus x1. If you were going to get rid of this fraction, you would multiply both sides by that bottom, and that's kind of where this guy came from. So m times the x part will equal the y part. And what point slope equation allows you to do is it allows you to write an equation of a line if you know the slope and any old point, like we just did on that last one. We knew the slope was, what was it, -2/3, and we knew the point was negative 3, 6. So what you can do with this equation is you can plug this in for x1 and y1, and you'll get y minus 6 equals negative 2/3 x minus a negative 3, which will be a plus 3. Some of you might say that doesn't look anything like the problem we just did. Well, the only way all the equations will look the same is if you get y by itself. So you would have to math this up a little bit to get there. We would get y minus 6 is negative 2/3 x minus, those 3's will cancel like we said, is minus 2. Or you can type it in your calculator, add 6 to both sides, and now it looks like we just had it, negative 2/3 x plus 4. So you can choose, do you want to do mx plus b or point slope formula? This time it gets one step even trickier still. This time they don't give me the m and they don't give me the b. They give me instead 2 points. So you have to use all of your tricks, and the first thing you have to do is find the slope, because all you need is m and b. So you're going to go ahead and find the slope first using your formula, change in y over change in x, which is y2 minus y1 over x2 minus x1. So we'll go ahead and do this. Here's my first point, so it gets the 1's. There's my second point, so it gets the 2's. Negative 4 minus 3 over 1 minus 2. So it looks like I'm getting negative 7 over 1 minus 2 is negative 1. That will give me a positive 7. So my slope is 7. From here, you have two choices. You can do the mx plus b route or the y minus y1 equals mx minus x1 point slope route. I'm going to do mx plus b first, and then I'll do this way second. So I know the slope is m is 7. So I have 7x plus b. I still have to find that y-intercept. So you can pick your favorite point. Either one is fine. I usually pick the one that does not have a negative to plug into the equation to find the b. So 3 equals 7 times 2 plus b. 3 equals 14 plus b. Subtract 14, and I get negative 11 is b. So now I know this m is 7, b is a negative 11, and my equation is y equals 7x minus 11. You also could have done point slope formula. You know what the slope is. The slope was 7. So you can pick your favorite point. Again, I like to pick the points with two positives, but you could have picked this one as well. So it's y minus y1, which is 3, equals m, x minus x1, which would be 2. And you would finish it up just like we talked about. Y minus 3 is 7x minus 14. Add 3, and you'll get that negative 11. You would have got the same answer if you would have used the other point as well. If you want me to show you, I can. It would have been y plus 4, because y minus negative 4 equals m, 7, x minus 1. Y minus plus 4 equals 7x minus 7. When you subtract 4, you will still get that negative 11 we talked about. So any of those three ways will work. We get the right answer either way you do it. Okay, next thing we're going to talk about is parallel lines. Things you need to know about parallel lines is parallel lines have the same slope. Their steepness is the same. So if they tell you that lines are parallel, immediately you know what the slope is of the new guy. So their slope is the same. If they were different, they would intersect. So they're parallel, they have the same slope. If they have different slope, they will intersect. Perpendicular lines, kids will forget this, so you need to make sure you remember, they do not have the same slope. In fact, if you look, if this one's uphill, one's going to have to be downhill for it to make a right angle, because perpendicular means makes a right angle. Okay, this is not perpendicular, but this one is. And if you noticed, one has a positive slope, One's going to have a negative slope. So they're definitely going to have opposite slopes. But more importantly, this one is steeper. This one is flatter. They have opposite what we call reciprocal slope. So this basically means you're going to change the sign and flip your fraction. So if the slope was 2/3, the perpendicular slope, that's the symbol for perpendicular, change the sign, negative, flip the fraction, 3/2. Those would be perpendicular slopes. If the slope was -4, the perpendicular slope would be change the sign, positive, flip the fraction, that would be 1/4. Now, if it's a parallel slope, that means parallel, and we're talking about the original, it would be -4 because those two have the same, these two have the opposite, reciprocal. Was that the same slide twice? Oh, they're talking about vertical and horizontal are perpendicular to each other as well. Okay, so let's look at one of these tricky questions. We are going to figure out if it's parallel, perpendicular, or neither. So we're basically just looking at the slopes. If they're the same, it would be parallel. If it's opposite, reciprocal, it will be perpendicular. And if they're just different, then they'll be neither. Okay, so how do we do this when we have equations like this? Y plus 2 equals 5x, and 5y plus x equals -15. Well, you have to get y by itself. If you get y by itself, you can easily tell what the slope is because it will be right in front of the x. So I have y equals 5x minus 2, and the slope of this guy is 5. Get y by itself here, and I'm going to subtract x first. So 5y is -x minus 15. Divide all the friends by 5, and I get y equals, there's a 1 in front of that x, -1/5 x minus 3. The slope of this guy is -1/5. How are they related? This is 5. This is a -1/5. They are opposite reciprocals, so these two lines are perpendicular. Looking at this problem, how can we tell? We're going to have to get y by itself. So I'm going to subtract the 4x. 2y is -4x plus 8. I like to put the x first so that it looks like the lines I'm used to. Divide all the friends by 2. I get -2x plus 4. Oops, little glitcher. So the slope of this first equation is -2. Let's see what the second one gives me. This one almost has y all by itself already. Just things are in a little bit weird order. If you divide all the friends by -1, I get -5 minus 2x equals y. If I rearrange that, the x has a -2x and then the -5. The slope of this guy is also -2, which is the same slope. So these two lines are parallel. One more example. Y is already by itself in the first one. The slope is 2. If I get y by itself in the second one, I would subtract the 3x, and the slope is -3. They're not the same. They're not opposite reciprocal, so these lines will just cross. They are neither parallel or perpendicular. Okay, this will be on your test or something similar, and kids kind of struggle with this. We are going to write equations of a line that is parallel and perpendicular to this guy. Okay, so the problem is they're asking us to do a lot of things at once, and we need to get a little bit organized. So first, they're giving me this line. And they're also giving me a point, 2, -3. And they want one that's going to be parallel, and they want one that's going to be perpendicular. So the first thing we need for anything is the slope. We need m and b to write the equations of lines. So first we need to figure out, well, what will the slope be? Well, it's going to give us the slope in this line. We have to get y by itself. So for y, if you add x, it's going to be x equals 20. Divide everybody by 4, and this line is y equals 1/4 x plus 5. So this is the line. If it's parallel to this line, the slope is the same as this line, which is 1/4. If it's perpendicular to that line, the slope is the opposite, reciprocal, which is -4. So now I know what the slopes are of both of my lines. I also need to know what the y-intercept is going to be, and I don't know that yet. I'm going to have to do some calculations using this point. So you can use mx plus b, and I'll use mx plus b here, or you could also do the point slope formula if you like that better. So I'm going to do mx plus b. I'm going to use my point and plug this in for x and y. So I have -3 equals m was 1/4 times 2 plus b, -3. This is 1/2 plus b. You're probably going to get your calculator out. You're going to subtract 1/2 from -3. We'll change it to an improper fraction. -3 minus 1/2. Then go ahead and hit math 1. It's -7/2. It's not wrong to say -3.5, but your math lab doesn't like that as much. So now I know the two parts I need. I needed the slope. I needed the y-intercept. My parallel line has the equation y equals 1/4 x minus 7/2. Now let's do this perpendicular one. We already know the slope. We have to find the y-intercept. So you're going to use that point to -3 in mx plus b, and we're going to solve it out. Y is -3. My slope is -4 this time, times x, which is 2, plus b. -3 is -8 plus b. Add 8 to both sides, and I get a b value of 5. So now I know my slope. I know my y-intercept. I can write the perpendicular line is y equals -4x plus 5. Again, if you wanted to do this with the point slope formula, you could have gone that way as well. I personally prefer mx plus b. Okay, what do we got here? So things you need to know. You need to know your slope, slope-intercept form. There's your point slope. Horizontal lines and vertical lines are special. And all these are telling you is that parallel lines have the same slope. It's telling you kind of in a fancy way. And perpendicular has the opposite reciprocal. When you multiply opposite reciprocal slopes, they give you the answer of -1. Next, they're going to talk about mathematical models. Mathematical models are basically just word problems. And sometimes we're going to be using our calculator to give us a linear model to fit data points. So this is totally a calculator problem. You will need to know how to do this. If you have a Casio, you might have to do a quick Google search. I'm going to see if I can figure out how to do it maybe on a Desmos or something. But I'm going to show you today how to do it on a TI-84. This is called curve fitting. It's called linear regression. It's called linear modeling. And this will definitely be on your test, okay? So you're going to want to write these steps down somewhere to be easy to come to. So here's how it goes. The cost of a 30-second Super Bowl commercial has increased 1.6 million from 2010 to 2015. So then they have this data here, and then they plot these dots, okay? They want to model it with a linear function. You can tell it's not quite linear. There's some that are a little bit above, but you can pretend it kind of is. And that's called the line of best fit. I'm sure you've heard of that before. A line of best fit. It's like an estimating line to estimate what will happen in 2018 if it follows that trend. So on your homework, they're going to have you do this two different ways. You need to make sure that you might want to view an example sometimes to see if they want you to do it by hand or if they want you to do it by your calculator. Now, if you do it by hand, all you have to do is pick 2 points, like they're doing here. This is the hand method. And then you're going to find the slope, use y equals mx plus b, use the slope and pick a point. You'll find b and you'll have an equation of a line you can use. Once you have an equation you can use, you can plug in 8 because that would tell you what would happen in 2018 to get a good estimate. But I want to show you how to use this linear regression model on your calculator, okay? So here's the commands that we're going to hit. Let's see. All right, the first thing you're going to do is you're going to get your calculator out, and you're going to hit a button called Stat. I'm going to write down my table first because you're going to have this table handy to do this. I'm going to probably do it right over here. Let's see. Okay, so I have X and I have Y. And it says 0, 1, 2, 3, 4, 5. It also says 2010, 2011, but I'm not going to use those numbers. I'm going to use the 0, 1, 2, 3, 4, 5. So those are not what I'm going to use. I'm going to use the 0, 1, 2, 3, 4, 5. I have a 2.9, a 3.1, a 3.5, a 3.8, a 4.0, and a 4.5. Okay, so here we go. Here are the buttons we're going to hit. We're going to go to our calculator. And the first thing we're going to do is we're going to hit stats because this is called statistics. And we're going to put this table into our graphing calculator. So we're going to go to edit and we're going to type in these X values into L1 and these Y values into L2. So you're just going to hit 0, and then when you hit enter, it'll hop down. So 0, 1, 2, 3, 4, 5. Then you'll hit the right arrow and it'll hop to the next list. 2.9, 3.1. We're going to remember those are millions, but these will help us. 3.8, be a little bit smaller. 4 and 4.5. So I have these in my table. If I wanted to look at the graph, if you hit graph, you see that, oh, I have an old graph on there. Sorry, let me get rid of this. There's nothing there. And the 0.0, 2.9 should be right in here. Well, that's because I haven't told my calculator that it can graph dots. So to make it graph dots, you will hit second y equal, and it says stat plot. You see how it says plots off? We're going to turn it on. You're going to hit 1. You're going to say, hey, go ahead and graph these dots for me. Now, when I hit graph, there are my points. Okay, now the next thing I'm going to do is I want it to make a line for me. So I'm going to hit stat again. And I already have my list in it. So I want it to go over to calculate. And I want it to use my list to calculate what I'm going to call linear regression. So that's number 4. You can either hit 4 or go down. And it's going to say AX plus B. That looks like MX plus B. You'll hit 4. And then it's going to say, hey, I'm going to use L1 and L2, which is just what you want it to. So you can just hit enter all the way down until it says calculate. And it tells me that A is 0.314. That's probably good enough. And B is going to be 2.84, let's say 8. So the equation of my line would be y equals 0.314x plus 2.848. Now, if I wanted to graph that, I could type it in. You don't have to do this part. I'm just showing you what we're actually doing here. All you have to do is come up with that line plus 2.848. And I hit graph, and look, that line is going right close through my points. Now, there's a second part of this, and it's called the correlation coefficient. The correlation coefficient is called R. And if R is close to 1, that's correlation coefficient, then the line is good. It could also be close to -1. It would just be a negative slope line. So that's why it says the absolute value. So if the absolute value of R is close to 1, then the line is good. Sometimes you'll have dots like this that are pretty far apart, and the line will go like this, and it's okay, but it's not close to 1 because it wouldn't be good. Our line, though, it looked pretty close to 1, right? Doesn't look pretty good? So we want it to tell us how close it is. So what you need to do is you need to hit second 0, which is catalog. And you should only have to do this once. You're going to scroll all the way down until it says diagnostic on. Okay, so there it is, diagnostic on. Hit enter one more time. Now, when I do the stat calculate for, it will tell me, there's the equation, that line, and do you see how R is 0.99? My R is 0.993. That's a good line. So it's a good fit because my R is good. Now you're going to forget these keystrokes. So it's really important that you do your homework and go over this so that you know what you're doing. Here's some examples of a really good R, an okay one, and this one is pretty bad. Okay, same thing is true for negative. So that's all we have for 1-4, and it's a lot. So make sure that you get a good start on your homework and ask questions if you have them.